Welcome back to Wes Explains Best. Today we're going to be doing a Kuta software worksheet tutorial for geometry on surface area pyramids and cones. This is in follow-up of the prisms and cylinders, so now we're doing pyramids and cones. Cones and pyramids are different than cylinders and prisms because they only have one base. So you can see here, this cone only has one base, and this pyramid only has one base. Now, this section is very important because in terms of trying to find the measurements of the net of each solid, because in my experience, pyramids have been very tricky for students to conceptualize in two-dimensional space. So it's kind of good to think about them unfolding, but we'll get to that in a second. We're going to start with the cone, and as you can see, the base is going to be this circle. There's only one base for a cone, and now we need to copy over the measurements. First, let's understand the measurements of the three-dimensional space. So this 13 is equal to the radius. This is the radius of the base. Okay, so that is the radius. Now there's an unseen distance here. This is called the height of the cone. Now that's basically saying how tall is the cone. If we laid it flat, how tall would it be? We're not using this actually though for surface area. We're going to be using it for volume. Now this unit, 30, this is the slant height. This is important to find the surface area of a cone. So right here we have 13. We're going to copy over our dimensions here. So this is 13. This is our radius. And then we have this unknown distance. But if we were to roll up this right here, this is the top. This is the vertex of the triangle, or excuse me, vertex of the cone. So that's what that is. And then you would roll it up and it would form the cone. So this is your slant height. So this is 30. And I don't think it gives this unit, so no, it's just 30. Now, I'm going to go ahead and find the surface area of this cone. I know it doesn't ask that, but there's only 2 cones on this entire worksheet. All of these are pyramids over here. So I'm going to go ahead and show you how to find the surface area of a cone. And if you're one of my students watching this, you need to find the surface area of the cone in 1 and 5. But for the pyramids, 2, 3, 4, and 6, I'm going to make my students just do the measurements for the net because there's plenty of pyramids to find the surface area of down there. Okay, but let's continue going on. Proceed is what I meant to say. Okay, so the surface area is equal to the lateral area plus the area of the base. Now, with prisms and cylinders, it was 2 bases, but now there's only 1 base. But lateral area remains the same. Now, lateral area is a little tricky. It's an involved proof, which I'll make another video for. But for lateral area of a cone, it's pi times the radius times the slant length. That's why I told you we're not going to use the height. It's going to be pi r times the slant length. And the base, we should know that's equal to pi r squared, and that's our surface area. So we can go ahead and plug in some of these data points, some of this missing information. 13 plus 30 plus pi times 13 squared. That's going to give us 169 pi plus 30 times 13. I'm going to need some backup on this one. I think it's 390, but I'm just going to double check that. I was right. 390 pi. And then I'm going to add this to 169, and I get 559 pi units squared. It's very important that you label correct units. Your geometry teacher is going to go nuts if you get to volume and you're mixing up with square units, and then you go to surface area and you're using cube units. It's very important that you label the units, okay? So that's how you do surface area. It's very simple. It's kind of like the pyramids, except the lateral area formula is a little bit different, and that's something you're just going to have to memorize for now. Okay, moving on. Let's go to number 2 is fairly straightforward. Let's go on to number 5. And then we'll move on to some of the ones down below. Okay, so for number 5, or I said 5, I meant 3. Okay, number 3, this one. Okay, so now we have this pyramid. Notice how we have a base here. I'll go ahead and draw it in blue, that's fine. Now we always want to look at its base to see what kind of pyramid it is. So we notice here that this pyramid is a pentagon. So this is a pentagonal pyramid. Okay, so when we fold it down, If it's a pentagon, that means it has 5 sides. That means it's going to have 5 triangles that fold up to form the vertex up at the top. So this is the vertex. So that's where the vertex would meet with all these triangles. Okay, so just imagine it folding down, and then it folds up when we want to form it. Okay, some important measurements here. Well, we have 8.9. This is the apothem of the pentagon. The apothem is useful for the area of the base. Okay, we're not going to be using it for the triangle, but it's very important for the area of the base. The other thing we need to know, so that's our apothem. The other thing we need to know is this distance here, that 13. That is this distance right here. That is 13. And if that's 13, then that means all these distances right here are also 13. So we got these measured, or labeled. Okay. Next up, we have 21.9. So we're going to draw this like this, 21.9. That is the slant height. Okay, so we talked about slant height before. This is the slant height of the pyramid. The slant height is useful for finding the surface area. Now, if we wanted to find just like the cone, this is called the height. This is useful for volume. That is the height of the pyramid, just like we had slant height and height for the cone, okay? Now, we need to find, well, actually, we don't really need to find. I was going to say we need to find these right here. That's called the slant edge, or the lateral edge, I mean. Oops, sorry, messed up my marker. Let's go here. This is called my lateral edge. But you really don't need to know that for surface area, because really all you need to find the area of this triangle is 1/2 the base times the height, and that's given. We have the base, it's 13, and we have the height, it's 21.9. That's not what this problem's asking, but I'm just saying that's why you don't need to know that green. These green lines, the lateral edges, because you only need to know enough information to find the surface area. Okay, so that's just kind of a breakdown of how a pyramid works. Let's go ahead and do a tougher one of these problems. Let's go, I don't know, let's do this triangular one. Okay, so here we have a triangular pyramid. How do I know it's a triangular pyramid? Because its base is a triangle. Okay, and really we could call, the reason why we could really call any of the sides a base, but since this one's on the bottom, I'll go ahead and call that one the base. Okay, so if we were to fold this down, I'm going to make that blue actually. I don't know why my undo is not working. That's very odd. Okay, so if I were to fold this down, I'm going to draw in light green. This is what it would look like, something like this. So that's why it's good to be able to visualize. Okay, so this is a similar formula to what we used for the cone. We're going to do the lateral area plus the area of the one base. Okay, so what we need to do here for the lateral area, we need to find the area of each triangle and add them all up. So the lateral area for a pyramid is going to be the area of the triangles. Non-base, the non-base ones. Okay, now we could do that. We could go across here. The slant height for, well, we notice that this is an equilateral triangle. The blue one is an equilateral triangle, so the dimensions are going to be the same. And we also are told that this slant height, this is the slant height right here. Slant height is 11.3 for each one of these. So this is 11.3, 11.3, 11.3. Okay, so we could go and, and we know this is 9. This is 9, this is 9. So we could add up each one of these triangles individually, or we could find one and then multiply it by 3 because the dimensions are the same. Or, one thing you can always do for lateral area, because they are triangles, we can do 1/2 times the perimeter. That way we account for all 3 triangles' bases at once, times the slant height. So that's another way, a shorthand way to find the lateral area is the perimeter of the base times the slant height. So we know 1/2 times the perimeter of the base. The perimeter of the base is 27, and we know the slant height is 11.3. So we can apply all that information, and that's essentially going to give us 11.3, all the lateral area divided by 2. Okay, so I got 152.55. And real quickly, I'm going to show how you get the same thing by doing it the other way. So I can do area equals of one of these green triangles, the base, which is 9, times 11.3, and then I multiply that by 1/2. So I do 9 times 11.3 divided by 2, or multiplied by 1/2, and I get 50.85. So if I multiplied this by 3, because there's 3 triangles, what should I get? I get exactly that. So I can use the perimeter. It's a much shorter way. Let me change it to here. The perimeter is a much shorter way of solving these problems, so make sure you keep that in mind. Of course, my undo button doesn't work. Okay, now, we already found the lateral area. We got that settled. We know that's 152.55. That's units squared, centimeters squared. Now we just need to find the area of the base. Now, with the area of the base, we know it's equal to 1/2 the base times the height. Be careful. There's a lot of bases being thrown around here. Big B means the entire area of the 3D shape. When it's a little b, we're talking about a length of a 2D shape. So we have 1/2, and the base is going to be 9. That's one of the sides. And then the height is perpendicular to that base. That is 7.8. So I'm going to do 4.5, which is 9 times 1/2, times 7.8, and I get 35.1. So now I have my area of the base plus 35.1, and that's going to be my total surface area. I'm going to add this to 152.55. I still have it stored. So I get 187.65 centimeters squared, and there's my answer. You're going to do the same thing for all of these. For problems like this, you're going to use the area of a regular polygon for the base of this guy, for that base. And that is 1/2 the perimeter times the apothem. So keep that in mind. All these other ones, you're going to still follow the same formula of the surface area equals the lateral area plus the base. Don't forget that lateral area equals 1/2 times the perimeter of the base times the slant height. Hope this was helpful, and I hope to see you next time on West Explains Best. Take care.